Thank you, class, and hello to everyone. I'd like to show you how EURO-CORDEX regional climate projections will be used for climate services. I start with the definition for climate services from the European Roadmap for Climate Services. This is the transformation of climate-related data into customized products counseling on best practices, development and evaluation of use for the society. Now I'd like to show you how at GERICS a co-production of a climate service product is going on. So on the top you see the users, so people who have a need for adaptation to climate change, and at the bottom you see, for example, climate research findings. This can be a lot of things, but it can also be climate data. And GERICS has this kind of meandering between the user and the climate data along the way, and they focus on climate change information and bring this to the user, and in the end they develop a prototype product and see if it's of practical use, and then at the final end a climate service product is developed. So for many of our climate service products we use the EURO-CORDEX data. It just got really nicely explained by Ole, and again you can see here the area of Europe which is covered by the EURO-CORDEX ensemble, and we use 3 scenarios. So the business as usual scenario, RCP 8.5, which has the strongest greenhouse gas concentrations at the end of the century, and RCP 4.5 and RCP 2.6. There was a question in the chat. So EURO-CORDEX is using CMIP 5 forcing. So not yet CMIP 6 forcing. So these are all from CMIP 5. And as Ole said, we already will have 132 simulations very soon. This is the really lovely matrix Ole is taken care of in the Principles project. And what I'd like to point out is that the most simulations are really done for RCP 8.5. So how is this technically going on? So we have, at the left-hand side, you see, we take the EURO-CORDEX climate simulations, and we take them from the ESGF at DKZ at the moment, because this is just next door from us. So this is very easy for us, but all these data is also stored at the climate data store. And we always use some observations. Then we use the GERICS climate ClimDex Python package for computing climate indices. We use CDO commands. And in the end, we have a database of climate change indices and simulations. This work needs the IT infrastructure from the DKZ, because it's a lot of data, and this data is not processed within a day. So you need weeks, and it really needs continuous update and people who really continuously maintain all this data and formats and indices and keep them updated. And then we want to produce a climate, for example, a regional climate fact sheet for a German federal state. So we calculate the area mean for the federal state and the robustness of the climate change signal, where we also use Python for programming these tools. So I like to show this product which uses the EURO-CORDEX ensemble. This is just an example of all the products we have. This is the regional climate fact sheet for the federal states. It is based on the report of climate Outlook Brandenburg, which was developed in cooperation with the Ministry of Rural Development, Environment and Agriculture of the state of Brandenburg. Climate fact sheets provide local decision makers with a comprehensive picture of the current state of knowledge of on projected climate changes for the region, including possible uncertainties. The data analysis procedures of the current report are based on the new GERICS software ClimDex and include a classification of the robustness of the model results. The fact sheets are structured in a uniform manner and allow regional comparison with each other. So the regional climate fact sheets for the German federal state are always structured in the same way. They start with the introduction, including a table of summary with the main climate change signal at the end of the 21st century. Then on the next page, they describe the climate of today, and then followed by detailed description of the projected results for 17 climate indices based on 3 RCP scenarios. Each climate fact sheet also contains the definitions of the climate indices, scenarios, categories, so you don't need any additional literature to understand what you get. I like to describe you, I'll show you as an example, the climate fact sheet for Hamburg. So where GERICS is, and Hamburg is in the north of Germany, close to the North Sea, and has a warm temperate climate. And this is just the observations from the German Weather Service, and at the bottom you can already see the increasing temperatures in the last decade for more than 1 degree. And on the right-hand side, you just see some examples of the indices which are described in the fact sheet for observations as well as for the scenario results. Something like summer days, heat days, ice days, like the 59th percentile of daily precipitation. Before I show you the scenario results, I like to explain you the symbols of expert judgment about the robustness of the projections. So there are 6 symbols. The significance is calculated with the Mann-Whitney-U test for each single simulation. So if we say that the ensemble, for example, for RCP 8.5 increases, at least 2/3 of the simulations have to show an increase, and at least 50% of them have to show even a significant increase. This would be an error upwards. And if we say the ensemble shows a significant decrease, at least 2/3 of the simulations show a decrease, and at least 50% of these simulations show even a significant decrease. So then the arrow goes downwards for the ensemble and is filled with a color. Unclear means not 2/3 majority of the simulations show a favorite direction, but at least 50% of the simulations show a significant decrease, a significant change. And there are also the symbol for tendency to increase, where at least 2/3 of the simulations show an increase, but less than 50% of the simulations show a significant increase. The same for a tendency for decrease, and there's also something, if not the majority, 2/3 majority of the simulations show a favored direction, and less than 50% of the simulations show a significant change. It means no change. I like to explain these symbols, which are used in the regional climate fact sheet for Hamburg, on an example. So you can see here all the simulations for RCP 8.5 used for this fact sheet, and you can clearly see that the number of heat days at the end of the century, also each single simulation shows an increase. And if it's a dark color, it's a significant increase. Only the light pink means there is an increase, but it's not significant. So if you want to know now how you have to put the arrow towards this ensemble, you have a look at the first decision rule. So more than 2/3 are in agreement in direction. So that and more than half of these show a significant change in this direction. So the arrow will be filled with the color. Another example. So the number of dry days in the middle of the century doesn't show such a very clear signal. So you see half of the simulations show a decrease and the other half of the simulation shows an increase. And it's always only 6 of the simulations show a significant increase or a significant decrease. So this means you have 19 simulations which show an increase. 6 of them show a significant increase. 17 simulations show a decrease, and 6 of these show a significant decrease. So less than 2/3 are in agreement in direction, so unclear direction, and less than half of the simulations show a significant change. So the arrow which will be signed up to the simulation will be empty. This is a typical picture for an indice, which is in a climate fact sheet. So you will find these results for each single indice in the fact sheet. So these are the heat days. So days is where the temperature maximum is greater than 30 degrees. And in this picture, you see the change compared to the reference period, 1971 to 2000. And heat days are very important to look at because the increase of heat days can harm the nature, animals, and the humans. And if we have really long periods of heat days, this could even damage the infrastructure. What you see in the line plot is the line for each single simulation. So the red simulations are the simulations which show the change in the RCP 8.5. The blue are the changes which the changes for RCP 4.5 and the gray ones for 2.6. In the corner, you can see box plots for the for a 30-year period, which makes it a little bit easier to compare the middle of the century to the end of the century and to compare the 3 RCPs with each other and their development with time. And you can clearly see that the temperature, the change of heat days is not so big into the mid of the century, but it really increases at the end of the century for RCP 8.5. And since the mid of the century to the end of the century, the change of heat days doesn't increase much or even decreases a little bit for scenario RCP 2.6. So these box plots always show the maximum and the minimum, the 80% and the 20% of the ensemble and the median. A fact sheet would also contain the numbers for minimum, maximum, and median. And now I'd like to show you the results and numbers. So if today we observe almost nearly 4 days, so heat days in the average over the control period 1971 to 2000, and they really increase in scenario RCP 8.5, where in the median shows the number of heat days increases about 6 heat days, so it would be more than double the heat days which we have observed now in the end of the century. And at the final end, you get this information about significance. So at the end of the century, all 3 scenarios show a significant increase. So the arrows go upwards and they are filled. One other example for an indice on precipitation. So high precipitations are dangerous for the infrastructure or could even cause floods. So daily precipitation days greater than 20 millimeters are very important. So again, the colors are always the same. So for RCP 8.5, this is always red, and for 4.5 is always blue, and so on. And you can clearly see that the climate change signal for precipitation is not as straightforward as for temperature indices. There are also simulations which show an increase and simulations which show a decrease. This means at the middle of the century, they show the change is towards an increase, but not significant. But at the end of the century for RCP 8.5 is the significance of daily precipitation days greater than 20 millimeters. And there will be almost twice as many precipitation days at the end of the century for RCP 8.5 than compared to the precipitation days at the observed period 1971 to 2000. So we don't do only climate fact sheets for federal state, we do them from global down to the local scale, but also we do climate, so horizontal maps of where we use the EURO-CORDEX ensemble. And if you go to the adapter project, you see the horizontal maps, which are kind of made in the same way like the federal state fact sheets. So you get an information about robustness and change, and you see what the results are showed for Hamburg, which are really in the north of Germany, kind of the climate change signal is not so strong like in Southern Europe. Also, there's the Impact to Sea Atlas, and if you enjoy, you can enjoy, if you like, you can enjoy a movie at the DKZ about the mean climate change out of the EURO-CORDEX ensemble. So there's this Project Glorious, or the water Project Glorious at the C3S, and they developed a quality assurance checklist that makes quality assurance transparent. You see an example for it on the right-hand side. So the QUAC was developed along an evaluation cascade, covering levels from general to detailed. So from dimension, criteria to indicator, to specially assess the level of quality for each indicator, a checklist with questions was developed, including guidance material. And if you'd like to find out more about this, the link is down here on this slide. Thank you for listening, and hello from Hamburg to you.